All right. All right, I think it is our time to begin. Good morning, everyone. Welcome to IPPM in IETF 103 here in Bangkok. If you are looking for IPPM, you're in the right place. If you're not, you can stay here and join us anyway. So I am Tommy Pauly. I am one of your new co-chairs. I am here on behalf of Bill and Brian as well, who are both unable to be here. And I'm sure we all wish Brian the best with his family. Here is the note well. If you're here yesterday, I'm sure you've seen this before, but please do note well. And the blue sheet should be going around. Let's see. Thank you. Right, blue sheets are going around. So we have a fairly full agenda. We do have a lot more time than we did. Oh, do you know where the echo is coming from? Oh, got it. Sorry, good. All right. So we have a fairly full agenda. We have a lot of working group document updates, as well as a bunch of lightning talks. Thank you, everyone, for that. I just want to give a quick update on some of our working group document statuses right now. So we have the 2330 IPv6 document, which had been in Auth 48. We actually have moved to Auth 48 done. It's fully approved. And so that will be RFC 8468 quite shortly. We also still have the TWAMP document waiting in misref for the other documents to come through. So that's fine. We have the TWAMP test document, got some AD comments from Miria. I think that has been updated now. And I think we're just going to wait for another approval from that, and that should be good. And since last time, now that we have more documents coming out of the queue, we have adopted a new document. So we've adopted the multi-point altmark document. So thank you everyone for chiming in on that. That was a good amount of feedback. All right, so here is our agenda. Please bash it if you need to. So we have the welcome right now. I'm going to briefly mention something about GitHub and how we can have people contribute in a more open area. That would be great to do. Al is going to give us some liaison updates, and then we are going to go through our documents in the working group. So we have those here. These are all the active ones that we have, along with the newly adopted document. And then we have a bunch of requests for lightning talks. Because we have limited time, I really do request that these be limited to just around 5 minutes per person. Some of these have more slides probably than will fit in 5 minutes. So if you can kind of trim down your content or give us the correct highlight reel, that would be fantastic. All right, so just one quick update about how we can collaborate and share the work and work together on this. There's been, of course, more of a push for using GitHub in working groups. I know that some of the documents that people are working on are already in various kind of separate GitHub repos. We do have a IPPM official repo, but it's, as you can see from the image here, fairly sparse right now, and there's really nothing in it. But I do want to highlight that there is this home for documents here. So I think some of the IOAM documents are already on GitHub, and so I think it'd be great if some of these could kind of come into the shared working group area, so that as people are coming and going and working on different stuff, we have a place so we can see these documents and a place for other people in the working group to contribute and give comments. Yes,
Frank Bruckner's one quick comment. We thought about moving. The problem with that is we're losing all history, right? If we move, so we can just pull the documents across.
So I think there are ways. So there's actually various strategies and stuff documented here. Just go you can look at these slides and follow these links, and we can follow up offline.
Okay, thank
There are
you.
various strategies for how to set up your repo and also how to migrate what you have and essentially have it show up under the umbrella of the entire group. So essentially, anyone who is a document author, or especially if you're starting new work and you'd like it to be considered by the working group, I invite you to please come here and work on that. All right, so moving on. If there's any agenda bashing, we can jump right in. I think the first thing we have is our liaison statements from Al.
Thank you, John. So X marks the spot.
Oh yeah, no box for you.
Right, no box. I'm gonna steal this though. All right. Okay, so it's liaison time. This is the kind of thing we do when we behave as a real standards body. We get, wait a minute, that didn't work. Something went wrong here. Oh, it goes like this. There we go. We occasionally get communications from other standards bodies, and we read them, and we take action, whatever's needed, and we respond back. So very quickly, there's a liaison that ended up in the liaison data tracker. There's a link for it there. And there's a huge number of standards bodies included in this liaison, including us in IPPM, but also a couple of different ETSI standards groups, a couple of different ITUT study groups, a couple of, IETF, BBF, maybe even some other organizations. So the whole idea of this is to try to harmonize this idea of measuring internet performance, particularly speed and latency, across many different standards bodies. I talked to a couple of people about this morning, Leslie Daigle and Dave Aran. And Dave Aran said, we've struggled with this long enough that maybe now people are willing to come together about it. And we also have an idea that if we evaluate different methods of measurement against a ground truth, a calibrated path, that we can really know something about how these measurements work. So let's hope that these concepts are valuable and that we can make some progress in this topic. You can see that from ITUT, where this liaison comes from, Al Morton, and my friend Rudiger Geib are the co-editors of a section of the IP performance metrics recommendation there, which we're planning to update with an evaluation plan and improving the metrics that are there as well. So here's the evaluation plan, the pretty picture of what we're going to do. This is phase one, where we're recognizing that access speeds are moving into the gigabit range and also having very low latency. We are seeing companies like Comcast in the United States announcing that they've got 60 million homes where they're offering gigabit internet access. 25 years ago, all the cable companies in the United States were offering television service to 60 million homes. Now, that's the contrast. And that doesn't even include AT&T's, 15 cities with gigapower and other offers as well. So this is coming, and it's coming fast. Now, what happens when that happens, when we get to gigabit? Today's access test methods, where they're using N times TCP connections, they are not going to be able to keep up with this. That's a pretty safe bet. But let's find out. Let's evaluate it. And there's also a crossover. In the benchmarking world, benchmarking methodology working group, that's the group I chair, we've been doing this for years with UDP streams, measuring gigabits and doing it accurately. And so we're not afraid of trying this in the production network with a couple of caveats. We know that we have to put limits on the amount of traffic we send, and therefore the amount of congestion we cause. And it's got to be a short test and all those sorts of things. But we've got new robust search algorithms that will let us encounter the problems that we get in a production world and live through that, searching for the maximum level, maximum offered load. So we've done some testing. We've replaced the access pipe, the big blue access pipe there, with a host, a couple of physical ports on it. We've got a traffic shaper on both sides on egress, and running the traffic through a vSwitch. We've got a test device there, basically running the test streams. And lo and behold, we got very good results with UDP testing and our new search algorithms. We need to get iPerf working in the same environment so we can test the simultaneous TCP streams. But this is the quick calibration here. We've got the device under test with our ground truth at 100 or 200 milliseconds. And those are the values we measured, 100.5, 201. In a laboratory, we should be able to do this, but I'll bet there's going to be methods of measurement that don't. So now's our time to behave like a standards body. We should have a liaison reply. Would people like to join this effort? I'd like people to think about that, because this is something we've been working on supposedly in IPPM ever since Matt Mathis did the BOF about 25 years ago. So what I'd like to see people do is contribute methods, perform calibrations in other labs, make access technologies available in the laboratories. That's the phase 2 of this program. And so let me know. We'll propose a reply, we'll put it on the list, and we'll do something together. That's the plan. Any comments on this?
So we have one person in the queue, Jose?
Oh, yeah.
Hi everybody. I am Jose Ignacio from Buenos Aires. Thank you all to bring up this subject. Just a little comment. Yes, perhaps the main problem to measure speed at a home link, internet home link, is that you need to block the link. You need to flood the link in order to do that. And this makes some interrupts for the users. Then you also bring up another problem, which is you cannot perform at the same time test in everybody home. Even in 1% of the home could be a lot of traffic into the network.
That's exactly right.
Perhaps
two great points.
Yes, but perhaps you, okay, I am bringing this up because I am working on this kind of the problem, and my approach is just to test in another way. I mean, perhaps measuring some information about the traffic, measuring the variation of the delays, you can make some inferences about the traffic, how the traffic behaves into the network. Yes, for sure, it needs more explanation than that. But I think that perhaps the idea is to find another kind of approach to do this.
Very good. Thanks, Ignacio. And Ignacio got in touch with me by email. He's sort of interested in joining up with this as well. So look, those of us who are doing this, we welcome you to think about it and join us if this is sort of a hot topic for you. It will certainly have tremendous visibility if we can manage to harmonize this across the industry. I think it's time. Thanks.
And people should just email you, Al, or
let's do it on the list.
Okay, so
yeah,
if
let's
you're
do it on the
interested,
list.
let's send it to the list. Thank you. All right.
Okay. So I owe you 4 minutes.
Yep.
I will make that
Keep it
back.
back.
I'll make that back easily. All right. So now we're transitioning to the topic of the registry and the initial contents for the registry. This draft is providing the initial contents, a set of performance metrics that will go into the registry we're defining for performance metrics. So you can see that we've done plenty of iterations here. Number 8 for the registry contents, and number 16 for the design of the registry. So that means that we're going to go through the next 4 slides really fast. Watch. Active, passive, and hybrid. Those are the kinds of metrics we handle with precision. I'm getting too quick here. Registry concept, versions 15 and 16, no substantial revisions. I did a little editing. I just read part of it and fixed some stuff up. Here's the registry design. We got different categories of summaries, metric definition, and so forth. This has all been really solid too. So here's what really happened in the metric contents. We're closing the opens. So the DNS response time and loss section, it now requires the support of the ID generation, so we can get query and response correlation. UDP one-way delay and loss, we did, that's in section 8. Now it's a periodic runtime. Runtime parameters are fixed, so that it was always a periodic test. It's going to look like a VoIP stream. We got 20 millisecond spacing, a low bit rate packet size, and so forth. Next steps, the lingering issues. We did not see the reviews of the TCP section that were requested or hoped for, or would be better if we had. And others have reviewed this section though. So I'm saying, let's not wait. Let's go. Request, working group last call with a deadline, please. Let's shake any final comments loose with that deadline. And the observation that longevity is unattractive for internet drafts, reminding you that we're at version 16 and version 8. So that's it. We're at a point of interaction here, Mr. Chairman.
All right. So yeah, thank you, Al. I agree with the idea that, yeah, these are long-lived drafts. They seem to be in pretty good shape. The recent updates have been minor. I think it makes sense to have these go into a working group last call. How many people have read the documents, just to recalibrate that? So first ever.
Yeah.
So are you familiar with the documents in general? Okay, so 6-ish, not huge amount. Have people read the most recent updates or looked at the recent diffs?
You just saw the
Not
diffs.
much. Right. Yeah, and they're pretty small. Okay, so these are quite long documents, so I think it would be a relatively long. You've
You've even
time.
read them, right, Tommy?
I have read
Yes,
them. Yes,
yes.
I have.
Good.
I have some written down. So I think actually doing a last call would be really good and a good opportunity to ask the whole working group to seriously review the documents in their entirety and kind of see that full flow. Does anyone have any objections to doing that? Are we good to go? Great. So yeah, I will start a last call on that, hopefully this week, and give a deadline to that. If people could please take the time to review these on your flight back home, maybe that'd be great.
Thank you very much, working group and Mr. Chairman. I will make a note that there is a section in the registry contents draft on RTCP metrics, which we will remove. So don't bother reviewing that. That was there kind of as a proof of concept that this worked across all these different metrics. And it was not intended to keep it. So that's going to disappear. Don't bother with your comments on that. Thank you. Okay,
All right.
that's it.
And now, Al.
Yes. So this is the last time you'll see me today up front. We've been working on the advanced unidirectional route assessment metrics. Ignacio, who you saw just a moment ago, Joachim Fabini, Carl Pinataro, and Rudiger Geib. So now we actually have 5 of us who have joined up on this group. So the quick background on this is that we first presented it at IETF 99. We got it adopted shortly after 100. We've generalized all the definitions so that it's more widely applicable in the version we put in at 101. And we got some good feedback just before and after working group session and at IETF 102. So we added Rudiger as an author. He's produced an MPLS appendix. Carlos added a reference for that, and that's in there now too. Yakov Stein, who didn't put this comment on the list, said, you guys are describing your route ensemble and your your member routes as an ordered graph. And that's the wrong term, he said. So we looked into it. It turned out Yakov was right. So we fixed this, and it only appeared in the draft in one place. So it was an easy fix, but now we've explained why we're choosing this term. Okay, so we've revised several methods. I'll get to that in a little bit. And we've added an initial section on this intermediate point path assessment. So these are two areas we're developing. Obviously, there's a lot of repetition in temporal repetition in measuring path hops and the different members of the ensemble route. And obviously, it would be good to recognize that. And so we've got this concept of basically retesting parts of the path, especially the parts where you're seeing, the load balancing and multiple paths, the equal cost multipath. So we've got a section on that. We're still developing a section on the this concept of routing class C, where we somehow discover if I have multiple paths through the network, what are the characteristics that describe whether packets go through those paths or not? And if we understand that, that's a piece of information that we can use in further testing. Specifically, we can use it with testing routes at a midpoint. If we have a path, if we have a flow of interest that we've discovered that we would like to be able to learn more about. For example, like a quick flow, where we've discovered that the spin bit tells us that the round trip time is unexpectedly large. Then we could make a trace route from that point, and we could match basically the context of that quick flow, discover the path, discover the hops where the delay is growing, and that might be good to know. So what are the steps to do that? The preliminary steps. There's probably some calculations here that need to be done in more detail and obviously not in words. But we've got the stream. It's described by a 5-tuple. We're going to calculate one or more possible hash values that could be governing whether how this flow is routed through the network. And it's ultimately these hash values that define routing class C. So then we'll have synthesized route measurement packets. And we will basically be trying to match the hash value and keep our checksum constant, so that the multiple packets follow the same route, just like we're doing with Paris trace route or MDA or whatever the various things are today. And when you try to do both these things at once, I think it gets interesting. So I had hoped to spend more time on this in the interim period, but I see Greg has a comment here. So please, Greg.
So if I understand correctly, you suggest to use hash value of the flow and match it with the hash value of the test packets.
Yes. And the idea, of course, is that you don't know exactly what hashing has been chosen, but you have. That's why I talk about it in plural here. You may have to calculate a number of these and then determine which one of those is the real one, the one that matters. You want me to bring in my mic?
There's idea for another approach, and I'll reach you offline.
Okay. Okay.
With some discussion.
Good. That'll be great. Thank you. So that's not working at all. Is that one working?
That is working, but it doesn't seem to be.
It doesn't work either. This doesn't work here.
So Greg has some other ideas about this, and he's going to contact me offline. Actually, Greg, we could do it on the list if you want. However you prefer. So back to the clicker. Oh, so we've got some lingering to-do items on this draft. CMP is Carlos. Frank's got it. Yeah,
Yeah, it works. Thank you, Frank.
Well done, Frank. You're a real engineer. Yep.
Yeah, you're hired.
It's knowing which is the right button, Frank. Well done. Yeah. Those soundboards are sometimes intimidating. Oh yeah. So we had 2 review volunteers. Aaliyah Atlas was sort of volunteered to review this. Oh, there she is. Hi, Aaliyah. Great, thanks so much. And Brian Trammell volunteered Yari Arco. It didn't work
didn't
out.
work.
I did see Yari last night, and I did not mention it. But I will try to talk to him about it during this week. So we have these other things we had to fix. They're on our list. Next steps, authors, we got to complete our to-do items. The working group and the authors continue developing these sections, input from others. So a wide appeal, please read this. I think it's useful information. It's a good background to what's being done in the network today, and also the measurements that we need to understand what we're measuring. I mean, right at the beginning of the RFC 2330 IPPM framework, it says, paraphrasing, understand the path that you're measuring. Do we do that every time? In my old measurement system on the backbone, we did. But I think a lot of the things I talked about on the liaison topic do not. So they may know the two endpoints. That's about it. So, I mean, there's more to do here, and stuff that can be routinely done that's actually quite informative. Not just measuring speed and latency during speed tests. ICMP off to the side, meaningless. So, and know your path. Know where your packets went. This is fundamental stuff. It's what our forefathers in IPPM told us we should be doing 20 years ago. Let's not forget it. So that's it. No actions here except to line up some authors, Tommy. All right. Anybody care? Or not authors, reviewers.
Reviewers, yes.
Yeah. We've got plenty. It turns out we've actually got plenty of authors.
We want more reviewers. I mean, we have the reviews pending, so that'll be great. But yes, I think everyone, if you can read it and send in your reviews to the list, that'd be great. Do we have any comments or anything now?
Okay. This is when this happens, it means that we're not really behaving like a working group. Everybody has to read drafts, come to the meeting and come to the microphone and said, I read the draft and here's what I want, or here's what I saw. That's what happens.
So can we have raise hands for will you be able to review this draft and send feedback to the list? Leah, thank you. Frank, thank you.
Sweet.
All right.
Thank you.
All right. So I think that's a good first round at least. So please do send that out.
Awesome. Thanks so much, everybody. I appreciate your attention on all these important topics. Please get in touch with me about any of them and my co-authors. And I think I gave you some minutes back, man. So you're in great shape.
You did. Thank you very much. I'm sure all the lightning talks will appreciate it. All right. So I think Frank.
Adjust the size a little. Sorry, Al. Yeah, I think it's not only me, it's Brian. He's hiding somewhere in the back. Maybe you can come up front. And we have Mickey online who's going to go and take the third portion. I'm going to go and talk about the update. So everything that is marked with a little blue star is covered in this particular presentation. There's quite a bunch of encapsulation drafts, and the number is growing, and I think that was expected, given that we're taking the IOM data fields into virtually any reasonable transport protocol, protocol that would carry things. And there is also a bunch of, again, IOM-related work popping up. So I'm very happy to go and see that. My stuff is really about the core document, which is the data draft, defining the data fields. And we are at revision 4 right now. And revision 4 is pretty much a reflection of the discussion that we had in the last meeting in Montreal. In Montreal, we already started to discuss adding a namespace identifier. And that namespace identifier is now in the document, and it is there to distinguish between operational domains. Let's remember we defined all the IOM namespace, all the IOM fields, data fields, with a notion saying, well, it's within a particular domain. It is within a particular namespace, but we forgot to add the definition of the namespace in the document. So that is kind of a fix into what we've been referring to for quite some time, but never ever really defined. So it's there to distinguish operational domains. It helps you provide context for fields that are there, like node ID, but nobody tells you how to interpret the node ID. Well, with namespace ID, you can go do that. And you can even differentiate different sets of devices that way if you really want to. So if you have one namespace for devices that support a certain set of options and another namespace for another set of options, you can easily distinguish that using namespaces. So it's a useful thing, and which is why it's in there. Right now, the definition is for 16 bits namespace identifier. And there's been discussions on, well, should that all be operator defined or not? Well, right now, the feeling is maybe not. So we want to go and allow for operator defined as well as IANA defined. Trying to figure out what IANA defined might really mean. That discussion is ongoing. And also how to go and carve up the bits. Right now, we had this thing like it's either or. I think that's reflected in the document right now. That might not be smart enough. We might even want to have a combination where you're saying, well, there is an IANA value, and the IANA value says it's only belonging to, well, it's applicable worldwide, or it's only applicable to a certain region, or it's only applicable to a certain, well, whatever domain, like anything Europe, because in Europe things are different than anywhere else on the planet, or whatever, right? I think we're just thinking of that. And you want to go and combine it with an operational domain, with an operator-defined definition. And well, the current way is not really cutting that, so that's an ongoing discussion. What is pretty sure is we want to have a default, and the default is all zeros. So, well, we'll probably need to go and churn that and update that as we learn more on how people really want to go and use the namespace ID and assign the namespace ID above and beyond what we have right now. It's there in all the different option headers. So it's there in the trace option header, it's there in the proof of transit option header, and it's there in the E2E option header. So no surprises there, given that, well, it's namespace, everything needs to be namespace. The other thing that happened with, we introduced the namespace, and that meant we needed to go and move the fields around. As we moved the fields around, well, we wanted to go and give credit to some of the requirements that we've seen earlier on for, well, 16 bits for option types are relatively tight for trace type. So I think we used up, correct me if I'm wrong, something like 13 or 12 bits already, and so it's getting kind of very close to 16. So we took the opportunity to expand to 24, so there is more headroom, so we can add more stuff. We want to be careful on how much additional stuff we add, so we're not going really onto kind of a tangent there, but we have a couple of bits to go and play with. Also mentioned at the last working group meeting, so some interaction is happening, right, for L, right, at Bytes. We had this thing that was called app data for the time being, and well, it's really namespace specific data, and we're calling the thing now, so it's editorial, but I want to go and call that out. So if people want to go and play with things that are just for them, that's the field, right? If you have something that you want to go and carry and trace data that you don't want to go and see standardized, but you still want to go and have that in your domain, that's the way to go and, well, put free format data. If you have more free format data, there is this notion of opaque state snapshot, which is a sub-TLV within that TLV. Harder to go and build in hardware, which is, I think, why we have the two options. There is one additional thing added as another trace option, which is buffer occupancy. So we already started to eat more bits. Ongoing discussion on, well, how much additional stuff we wouldn't really want as a baseline in the document. Again, discussions ongoing, given that we have a few additional bits, not many, but a few additional bits to go and play with. And that's it for the data draft. We can take questions at the very end on all of the things. If you like going that way, then maybe, or we can take it right now. But Brian, can you go? There you are. Go ahead. Go ahead.
Okay.
I'm still here.
Okay. Robin for Huawei. I have several following comments. The first one is we have the hackathon in the
Very
yeah,
good
yeah,
point.
IETF meeting. Yeah.
I should mention that.
Yeah. Okay. I know. In the when we based on the VPP to implement the IOM, so we found some of these the issues, some of the apparent errors in the current draft. Yeah. I sent the comments to the mailing
So,
list.
Thank you so much for doing that. So what you did is great, and you caught a load of editorial nits. And loads of these editorial nits somehow happened when we did the 03 to 04, because, well, we grew the field from 16 to 24, and then, well, not all the calculations kind of caught up with that.
Yeah.
Great stuff, and we'll make tickets for all of that on GitHub. There is a bunch of other editorial tickets that are lining up right now. It's, well,
Okay.
good that you've done that, and I think that's showing another benefit of the hackathon, right? As people are trying to go and reason about the latest version, and I think one of the objectives of the hackathon was to implement the 04 version.
Yeah.
You suddenly start to stumble across all these little things that, well, we weren't too careful about.
Yeah.
And so thanks for keeping us straight here.
Okay, thank you.
Good stuff, thank you.
Okay. Second one is IOM, the encapsulation. In fact, I think the SR and MPRs are important scenario. So for the MPRs, I mentioned that in the MPRs working group, we propose the draft called the MPRs extension header. That means the extension header is try to encapsulate between the MPRs label stack and the payload. We hope the MPRs extension header can incorporate the IOM data and the SFC data. So I think that's is the idea. So later for the MPRs, we would like to discuss this topic. Yeah. So I think.
Do you have a lightning talk on that?
Yeah. Yeah. That's.
Has he? Does he have a lightning talk on this thing?
No. I'm not
Okay.
Latin tag. I just mentioned that
Okay.
you mentioned this encapsulation. Yeah. So I.
Okay. No.
Yeah. Okay.
Thank you.
Okay. So.
We can add that to the list. That's what he's saying.
Yeah. And the third one is when also read the draft, it's mentioned the SR and the IOM. So I think that need some alignment between the SR OM and the IOM header, because some of the IOM information hope to be encapsulated in the SRH. So, but I think the SRMPRs and SRV6 may have the different process.
Yeah.
Okay.
So I think we even have a few people that take care of the SR encapsulation of IOM in the room.
Yeah.
And we can either chat about right now or, well, maybe real quick.
So I think in the lightning talk, we have two drafts, one from Rakesh, from us, that we could go over some of the encapsulation details. And
cool.
So there are, I think, the two proposals for MPLS encapsulation.
Okay.
Thank you. Brian?
Hi, folks. This is a short draft, a short presentation and describing when the IOM option and data space is valuable to be sent in its own Ethernet encapsulation. And basically the little...
Can I get just chime in 1 second? So I think this is an updated version of the GRE draft that you shepherded prior, right? And I think it was Alia to inspire in the last working group meeting. Well, if you do something either type, do it generic for all either types instead of just doing for GRE. And I think that's a reflection of what Brian's going to go present here.
Great.
Actually, I have a question on procedure. So this is individual draft. Why we're presenting it not in the lightning talk? Why it's in between of the working group drafts? Eating the time.
I mean, I think this was, I guess, lumped in with the IOM work.
But it looks like hijacking.
Fair. Do you mind if we could?
I mind. Because it takes time from writing.
Okay.
In the same boat.
Can you be 5 minutes?
I can be less than 5 minutes.
Okay. We're doing pretty well on time, so I think we're going to leave it here for now.
So this is the motivation for the draft. As Frank pointed out, we've made it more general from before. This is really just a very simple encapsulation. It's the IOM option data space with its own little header, like you'd expect for any kind of a ether type. And the next protocol points to the next ether type in the list, whether it be IPv4 or something else. And the only little difference in here is that we've also defined that the next protocol could be an IP protocol number, which is for a different use case when you want to include this as part of an IP stack. But in general, it's intended for Ethernet. So it's very simple then. Here's an example of how you'd fit this with GRE. GRE is going to point to this, a new ether type that we were asking to be defined, which the first payload in the GRE then is simply what we saw on the previous screen. And then it points to whatever comes next. And you can do the same with Geneve, actually. Again, the Geneve header will just point to an ether, has an ether type that will point to the IOAM ether type that we're going to ask for. And there it is, and then something follows. And that's really the entire draft and entire presentation. Any questions? Okay, thank you.
Looks like we have one question. Oh, yeah. All right,
Yeah.
go ahead.
Yeah, can you hear me now?
Yep.
Okay. So I assume someone will forward the slides.
Yeah, I'll drive the slides. Here we go.
Okay, so it's pretty similar to the 0.0 version that we had before. The updates, one is on IOAM encapsulation type. So as you saw, the NCAPs there are new NCAPs being proposed. So I added a code point for IPv6, hoping that something will move forward with the IPv6 NCAP. And Geneve now has two options. One is within Geneve using an option class, and the other is what we just heard, using the ether type and an X protocol type of approach. So just threw code points in for that. The main change is to add two new information elements in order to optimize the use of IP packet section and Ethernet frame section. So these were issues that I noted last time, and last time there were some comments that it's not really possible to change the definitions of the existing information elements. So this is kind of parallel information elements, and whether you want to use these new ones or the old ones, I don't see any reason to preclude using the old ones versus the new ones. So if we can go to the next slide, we can see what is it trying to solve. So right now there's an IP header packet section, and I'm proposing an IP header packet section with padding. And so if you look at the padding rules for the packet sections that are used in IPFix, they more or less make sense for fixed length, but for variable length, it doesn't do everything that you want to do. In particular, if you get, say, an IP packet and it's not a multiple of 4 octets long, then how do you preserve alignment, especially if you have subsequent information elements or subsequent records within the same set? And that's the main thing I wanted to solve here. So allowing, if it's variable length, up to 3 octets of padding, and if it's fixed length, allowing, even if section exported octets is not present, I thought it was thinking that it might make sense to still allow a full packet to be in there and then padding after it if the full packet is smaller than the fixed length that was specified. So this was just trying to give us more ways to do the padding, not necessarily having to have the section exported octets, and allowing for variable length and still keeping the 4 octet alignment. Next slide. So So the definition of the IP header packet section, so the first 3 paragraphs are basically the same as what's in IP header packet section, the original. And then with padding, just reorganize the wording. So instead of talking about whether you have section exported octets or not, it's just organized the other way around to fixed length or variable length. So if it's fixed length, you can have an arbitrary number of padding octets. If it's variable length, up to 3 octets of padding to give you your 4 octet alignment. And either way, you can either say how much you included using section exported octets, or you can work off the length of the IP packet and pad after the end of the packet if it happens to be shorter. Next slide. So Ethernet, so one thing, if you want to do a layer 2 packet section or an Ethernet packet section, so one issue is the padding, which is the same as what's being proposed for the IP header packet section. The other issue is that right now the section is a data link frame section, which could be Ethernet, could be 802.11 or so on. So I wanted to propose something specifically for Ethernet here so that you don't have to include the data link frame type and data link frame size. So that's pretty much the new content. So some of it was the NCAP stuff, just aligning code points. And then there are these new IP header packet section with padding and Ethernet frame section are the new proposals for a couple of the new information elements. So that's all I had. I guess we can move on to questions.
So Mickey, Frank Brockners, did you chat to Brian on the new proposed fields?
No, I haven't done that yet.
He was suggesting that, and maybe you can give some guidance on how likely it is to go and get additional fields into IPFix, right? So I think that was the main question. Okay.
Yeah, I don't think the problem is getting additional fields themselves, but a concern was raised at the last meeting that the old text on security considerations might not be sufficient. And yeah, we could use some feedback on that.
Okay, thanks. And if we just roll quickly to next steps.
Do you want to come back up?
So from a next steps perspective, I think on the data draft, we definitely have to go and do an 05 version with all the editorial nits, but also closing on some of the discussion items. Mm-hmm. The document is getting pretty mature, so hopefully we can do either the 05 or 06 for working group last call. That's what I'm really hoping for, so we can close on that. Because we've already seen some people, well, I'll not say bitching, but close to that, or unhappiness about, yeah, well, you're still moving fields around, we're putting things into hardware. Yeah, fair point. So we want to be stable as quickly as we can. From an export draft perspective, so Mickey's done a few additions, but I think I want to see whether people feel like that's stable enough to eventually consider at least working group adoption. And more of a note, and that note is to our friendly AD's point in the last meeting, make sure that you're doing kind of parallel review process with all the working groups that shepherd a particular protocol that we're encapsulating into. That's pretty much an ongoing process. So there is review happening this week with an NV03 on things that are related to Genève. There is reviews happening later on today with regards to 6-man and the V6 encapsulation. There is a review, correct me if I'm wrong, Ali, so far if things are working in spring with regards to the segment routing stuff. So I think we're trying to go and progress that and get feedback in parallel for all the various working groups. And then I see Sam nodding his head on NV03. So that's more of a heads up. If we can, I think the default is still that we're trying to go and keep all the protocol work here so that IPPM has the broadest view on the whole thing. And yeah, that's all I had to say. Miriam.
Mia Kulevin. It's not our decision if we want to keep the work here. We have to coordinate with the other working groups and decide where those drafts go.
Yeah.
It's not only about review, you have to figure out where the home is. And I already started coordinating with the other area directors and chairs on that.
So who is we?
The chairs.
Okay.
I'm just saying, like, be prepared to move that over if that's a decision.
Yeah, well, I think, there's one thing missing here, that's the NSH draft, which is in SFC. Wherever things progress the quickest, we will go wherever it takes, right?
I can't promise you the quickest, but it's the right way to do it.
Right.
I just realized I didn't coordinate with the spring working group, so I will do that as well.
Yeah.
Thank you.
Thanks.
Yeah, it's Hao Song from Huawei. I asked a similar question in the email list. I'm still a little bit confused about the ether type. Shouldn't that be standardized in IEEE? And if we can define ether type here, and what's the procedure for the liaison with the IEEE? And I guess that's my question. And why you want define the ether type in the GRE and NV and Jenny? So I think I'm still a little bit confused.
I think the only thing that we're requesting is a code point, right? We're not defining anything Ethernet here.
It's called, why it's called
We're
ether type?
We're using code points from the Ethernet registry for our purpose. That's what we do. In order, if there is a registry, let's just use that.
So will require the IEEE takes the same number on. So maybe in the future you can also add that header in the layer 2 Ethernet packet. Is that possible?
Yeah.
I'm not sure that I follow.
Yes, Greg Mersky, I second the previous opinion because code point requires definition. Because if code point is not allocated, it's valid to drop the packet. So it's probably not the behavior you expect. If this code point expects some processing that has to be defined, and if this ether type happens to be on Ethernet packet, on the Ethernet frame, then what's the proper behavior? So I think that at least we need to liaison with IEEE and ask them for their opinion. If they want it to be this work to be done at IEEE, then that has to be it. I don't think that IETF has either type registry assigned or range from IEEE. We do have MAC addresses, but don't think that we have either types. I might be mistaken.
Sorry, Aliyah Atlas. So the IETF goes to the IEEE and requests Ethernet type allocations occasionally for drafts when they have been approved. We have an agreement with the IEEE for liaisoning. This is really pretty well, I won't say it's pretty common. We've only done it like 3 times in the last 2 or 3 years, but it's not unusual.
So that's what we have to do.
That's exactly what we have to do.
Process, yeah.
And Martin knows how to do it because he got soccer. I mean, had to do it for one of the drafts that I left, I think from, I don't remember, I think it was from Trill. But we also did it for NSH, for instance. Sorry?
After draft.
Yes, but the process can take a while, and given our relationship with IEEE being so absolutely excellent, you could probably put the request in after working group last call or something. And it will take some time. It does usually take about 3 months or so, and then you need to sort of sometimes encourage them.
Sounds reasonable.
Just to add to that, it follows the expert review process. There are 2 expert reviewers in IETF who can coordinate for that.
Robin from Huawei. Another question for the encapsulation, because we have a much discussion with the operator and the OTTs. They have much interest in the IOM. This is very useful. But you know that for the legacy devices, they are supporting the IPv4 in the existing network. So they hope that can also be supported the IOM. So I want to know what's the opinion in IETF, because from our point now, the most people think the IPv6, but legacy devices, a lot of the IPv4 traffic. So, but this seems a practical requirement. So do we need to do some encapsulation definition for IPv4, or just no future for IPv4?
Well, I think I can second the question that we get, that people want to see something defined for v4 or a solution for v4. Do we have a draft on that for now? I don't see any.
Yeah, I think that's just we think want to collect opinion from the IETF community, so when defend. I think the definition is simple, but it's yeah.
Well, the definition is not that simple, but but there is definitely a desire to have something.
Right, so we're getting close to time on this, so if we could cut the lines.
Yeah, and
what a cool shirt. Well,
we tried. I'm Spencer Dawkins. I'm the Irresponsible Transport Area Director for this working group now. It was a pleasure. When Leah was talking about the relationship with the IEEE 802 people being excellent, we're actually having breakfast with them for a coordination meeting on Friday morning. If you all wanted to give them a heads up and just see if there's at the 50,000 foot level, this is coming. Is there anything that, like, have you guys decided to stop allocating them? I mean, at that level of heads up, it might be helpful to do that. I don't know who else is going to be at that meeting right now, but some other people in this room may be better to do that. But I'm planning on being at the meeting if nobody else does. So happy to help.
Could you do that 5,000 foot heads up for us?
Maybe if
and just drop me a note about it. And
just have the authors kind of write a note to Spencer.
And I actually still read the mailing list with great interest on all these topics. So even just following up on the mailing list would be great. Thank you.
Thank you.
Hi, Barack. Melanox, just to comment on the v4 question. So we do also see a lot of interest in the v4 use case, definitely. We started working on a draft, at least I started working on a draft towards that. The problem is where to put all these kind of bits, because v4 is very, very restrictive. Just a note, actually IPv4 already have some kind of IOM inside. The ones did it tens of years ago already thought about it, but it's very restricted in terms of what can you put there. Our problem today is how much can you
route
put
recording.
There. Sorry?
You want route recording back? You want route recording in v4 back?
It's there, right? So.
It's there, yeah.
Okay, I think we cut the lines, so yeah. I think we should move on for time for now.
Thank you.
That's fine. You can send it to the list. Yep, and so just to follow up for the interaction with the other working groups, I guess if we're doing those presentations there, let's just make sure for each of those to have a good statement of if they want to take it there or if they want to have the work be done here. All right, Greg.
Okay, so update on STAMP-based protocol. Quick recap. So it's an active measurement OEM protocol compatible with the T1 test to reuse packet formats, and changes introduced backward compatible with the T1 polite. Default values reflect or configuration simple activation of a stamp. Configuration supported Yang model, and Yang model is another working group draft that we have working on. And new functionality introduced to STEP may not be supported by T1. So there is extensions using TLV, and we have individual draft for your review and comments. Appreciated. So this is a packet format for stamp sender everybody familiar with the TWAMP or OWAMP will see familiar structure. And this is the reflector for unauthenticated. So what was added in the latest update is the section on authentication and encryption operations. So the data integrity is supported by HMAC using SHA-1, truncated to 16 octets, very similar to what's done in OWAMP and TWAMP. Actually, we follow the same methods and procedures used in OWAMP and TWAMP, but it would not be guaranteed interoperability between nodes because the generation of the keys may be different. So making keys compatible is different because OWAMP and TWAMP, they're using a SID information to generate keys locally. So, and SIDs are exchanged through the TWAMP control and OWAMP control protocols. So confidentiality is encryption, and again, it follows the same familiar procedure from OWAMP and TWAMP. So that's the all update. Welcome comments, and authors believe that we're ready for the working group last call.
Great. So can we see a show of hands of who's read this, or are there any comments? Yeah, let's first see who has actually read the document.
I read an earlier.
So just a couple hands. Okay.
I had one quick question, Frank Rogners. You're encrypting and you're using 128-bit HMAC right now, right? What if somebody would break it? What would go wrong?
Break what specifically?
So the encryption, the authenticity. So if somebody would insert something fake. So what is the threat vector that you're protecting against?
Well, we're protecting against somebody spoofing measurements and creating false negative or false positive on the picture of the condition of the network, because performance monitoring is important as to verify that certain service receives the expected SLA. So operators care a big deal about it, especially for the premium services. So if somebody spoofs measurement results, so it's not only a tag because it's more computational load, but at the same time, it changes the perception of the network state.
Okay, well, I think it would be good to go and I understand the threat, but what is the kind of thing that you're really protecting against? What if somebody would really break the measurements? Because 128 is breakable, right? And I think I'm just wondering kind of why you chose that one. And well, if somebody would go and break it and put fake data in, is that really harmful? Yes, no, maybe, but just the thought.
Again, it's what TWAMP does and OWAMP does. It's better than nothing. That's, I believe, you would not argue. So if it's good enough, well, let's discuss it. Yeah. Yes, please. So we have another coming to the mic.
Hi, Florin Babescu, Broadcom. Personally, I think it's stupid because we are discussing here encryption for measurement. We are not reproducing traffic after a while. The overall computation actually to break a 128-bit message for a measurement packet into an active measurement report. It's kind of strange.
All right.
Okay, I have a question back to you. I'm sorry. Are you suggesting that measurements don't need to have any protection, any security?
I haven't said that you may not need in certain cases protection. However, a very high level of protection is not worthy from the end node perspective. It comes at a cost.
No, of course, we understand it, and that's why we have, as similar to TWAMP, OWAMP, there is unauthenticated mode, there is authenticated mode, and there is encrypted mode. You know, choose your poison.
Yes, the problem it is how much computation would you like to put on each of the end nodes? That's
Again,
the overall question. I mean, 128-bit, it's more than enough for a measurement. I believe it's an overburden.
Are you happy?
I'm happy.
You're happy
That's
with
why.
this as is?
Yeah,
That's
I
your
was
argument.
commenting on the previous comment.
Yep. Okay.
Okay. Thank you.
Thank you.
Okay, I misunderstood because again, there are different modes, and implementers, operators can choose whatever they prefer.
Briscoe, your argument was about integrity, but have you got an argument that anyone ever wants to use confidentiality? Given they're measuring stuff that you can measure yourself, so and that's not about processing, that's about implementation. You know, if you're making people implement something that no one's ever going to use, then I mean, certainly integrity and authentication.
In my past experience implementing TWAMP, yes, there is implementation with a TWAMP encrypted and authenticated mode. How much it's used in the field, that's a different discussion.
Well, that is the discussion, yeah.
Okay, from anecdotal evidence, I know is most of deployments use TWAMP Lite, which is unauthenticated and not encrypted.
I think Ignacio is next, so I'm going to let him through.
Well, hi again. Just to add that sometimes not authentication, but verification of the information is very useful for some kinds of protocols. For instance, if you are doing some clock synchronization, it's very useful to know that the data that you are sending are really good. And I think that it's in some context there is needed this kind of security. But I also agree that 128 bits is not enough for that. Perhaps you should consider to change that to 2056. Thank you.
256 to 156?
Yes, sorry, 256.
Okay, yeah.
Brian Wise.
Yeah.
So, yeah, I think HMAC SHA 256 or something is the more appropriate for any new protocol that we're adding attached to tag to these days. I would say that adding an HMAC integrity tag is very reasonable in many cases. You have to be a little more careful with confidentiality and how the encryption actually is done. So, for example, you're suggesting ECB mode for the first 8 bytes in the authenticated case, which I guess that must be authenticated, but ECB is not a mode we actually really use because these days it's nice that it doesn't expand, but it doesn't really have a lot of good properties as other modes of AES. And then in the other comment is in the encrypted mode, you're using CBC, which is good, but you have to have an initialization vector for that. And is that in the packet, or otherwise, how do you derive that?
Well, actually, since we are not defining how keys are distributed, yes, we can describe their process of initialization and what it should be, but again.
Well, traditional method is to have a random IV, or mostly random IV, and it's percent in the packet. We tend to prefer, or the cryptographers tend to discourage using, for example, the same IV across all packets in a stream and this sort of thing. So it's just something you want to pay attention to, and that's why I say, really, there's a lot more complications to adding confidentiality. You might want to just restrict this to integrity.
Okay, thank you.
Great, thank you. So I think we're going to move on time-wise. I think as far as next steps for this, based on the new stuff that you've added for this confidentiality and integrity protection, I think it'd be good to have some of these reviews and comments brought to the list, do a little bit more review on that.
Well, that is one way, but at the same time, it could be a part of the working group last call reviews, and then we'll address them all together as they come.
Sure.
So maybe just do it a little bit extended.
Yeah,
time
I think
frame.
at this point, because we have some of the other documents that look like we could be getting to working group last call first, so we're probably going to run those first, and then if people can give some of these comments that they just had onto the list even before we go to working group last call for this, that would be great.
Yeah, that's of course. Yeah, we will be just responding to comments and working with the reviewers.
Perfect. Thank you. All right. And our newest. There you go.
Okay, thank you. Okay, I'm Mauro Cociglio from Telecom Italia.
Can you grab the mic?
Oh, excuse me. I'm Mauro Cociglio from Telecom Italia, and I will present the last version of this draft that is just become adopted. Okay. To go ahead.
Oh, is that not working?
This is the second slide.
Sorry, let's just pull this up again. Yeah. Try to pull it up myself. Okay. Here, let me try to get on my machine. That's good.
Just like before.
Yeah, no, it keeps skipping. Well, all right.
Okay.
Let's just go like this.
Okay, the idea is to generalize and expand alternate marking. Okay, yes. It's to generalize and expand alternate marking. We create, for monitoring purposes, new flows, joining several point-to-point flows. So in the RFC 8321, we have a point-to-point flow. In this case, we have multi-point to multi-point flows, for example. So we have less counters and we have less computation in the monitoring points in the management center. But we can add some flows and we can split the network using our concept of cluster in the network. Okay, we can go. The idea is to have a monitoring network. It works if all the ingress point, all the egress point of a flow are monitored. And we can put in the middle the blue circle, no, the green circle, some intermediate measurement points. If all the ingress and all the egress are monitored, this system works. So we can design a monitoring network that is formed by all the monitoring points and the link, the virtual links then connect these monitoring points. For example, we have some kind of application that demonstrated that we can reduce the number of flow that we can monitor. The first one is VPN. Usually in a VPN, we have to monitor a lot of flows because to monitor all the point-to-point flows, if we have, for example, 1,000 VPN endpoint, we have 1 million of flows that connect any to any. If we define a flow as one flow for each VPN endpoint, this flow is a one point to multi-point that connects one endpoint of the VPN to the other points. So in this case, we have to monitor only 1,000 flows for 1,000 endpoints. Naturally, in this case, the monitoring is less precise, let me say. It's precise for the entire flow, but don't identify the precise flow, point-to-point flows where the loss, for example, the packet loss happened. In this case, we can split the network using the cluster concept. The other are very similar, so we can skip. Okay, the principle of this cluster division of the network is the packet loss property. In a packet network, the number of lost packets is the number of input packets minus the number of output packets. This is very trivial, but if this property is intended not for the whole network, but for single subnetworks, we define a principle that permits to individuate the smaller subnetwork in which this property is valid. In the next slide, we show a simple method that permits to split the network in all the cluster. Cluster is the smallest subnetworks that maintain this property. The algorithm is very simple. We group all the links for the starting point, and we obtain 5 groups in case of these graphs, and then we join the groups that have almost at least one ending point in common. So we join this group, and we add 4 clusters. This means that in each cluster, we don't know how many packets are lost for each links, but we can know only how many packets are lost from all the ingress point to all the egress point. So it's not precise, let me say, but a more general principle that can individuate the area of the network where the losses happens. If we want to have a more precise, we have to add other intermediate points, choosing other interface in the networks. So it's possible to split the cluster, adding other measurement points. For the delay measurement, there are 2 possibilities. If we consider average delay, we can measure the average delay for each period of the time that in average a packet have to cross a cluster. So for each cluster, for each period, for each flow, we can have an average delay. This is not so precise because it's an average. If we want to have a single packet measurement, the topology is used to select the point of measurement on the basis of cluster. So we use the hashing to select the packets. In the next slide, I think, yes, in the RFC 5475 is show the method that permits to select some packets and to individuate the packets in different points of the network. In this case, we collect all the packets for each cluster in the input point and all the packets in each cluster in the output point. We can make some comparison to individuate the same hash, individuating hash. So it's possible for each packet to follow the path. So the measurement is not multi-point, it's point-to-point. The multi-point network and the cluster concept permits to have less computation, less slower field of packets to compare. There are two possibilities, but we can skip. There are technical. Okay. There is a draft Sambonet mode Young FSM that define an application of this method in order to have a sort of feedback during the monitoring of a flow. We can start to monitor a big flow, for example, all the traffic. There is no filter on the traffic, so the counters runs every kind of packet can pass. If there is a problem, we can select the flow. So we split this multi-port flow in smaller flows, or in another case to zoom physically, not to consider all the networks, but consider the cluster inside the network or group of clusters, because the packet loss property works also for group of clusters that are connected. So in this case, is defined as a state machine that works in this way in order to make a dynamic monitoring. Okay, this is the summary. It's very simple. A controller can calibrate performance measurement. Dynamic performance measurement is introduced. And alternate marking plus hashing technique plus cluster help to perform optimized single packet performance analysis. So we put together many methodology to optimize the performance analysis that is very complicated to do without this, let me say, segmenting of the network, segmenting of the flows. The working group just adopted this draft, so we can, I hope, we can begin the path to become RFC. Thank you.
All right, thank you. Any questions, feedback on this? All right, thank you very much. Sorry about the poor quality of the slides.
Yes, but
presentation here.
If I convert in PDF,
yeah.
can work.
PDFs are good. All right, so now I think we are on to our lightning talk time. So we will begin that, and I'm going to try to enforce a 5-minute limit for each speaker. So choose which parts you want to focus on. Yes, PDF is good.
Thanks, Chair. I'm Jay from Broadcom. And as earlier during the IM conversation, the point was made that the problem is with the V4, and measuring the V4 information is very important. So this proposal came out of that discussion, and idea is very simple, that we want to be able to measure the metrics for the V4 traffic, which is 80% of the traffic in a data center, TCP UDP traffic, and the scheme should work seamlessly for IPv6 traffic, any other kind of tunnel traffic, and MPLS as well. But this presentation is focused only on IP, not on MPLS. So the requirement which came to us, that there is a deployment where the protocols fields are already used. Let's say the VXLAN header, the field is used in that, and we cannot really have a new GPE extension to use this. So is there a proposal which can use the existing format? Same thing is on the IP. Some folks use the DSCP bits. Can we use something where I'm not relying on the DSCP bits? So that was kind of the proposal. The other thing, very important, is that the path of the packet should not change, meaning that the L4 headers and the information in the L4 headers should be preserved. I'm trying to go fast. So that was a protocol requirement. On the operational side, I think this is something which came in the conversation, that the insertion of the metadata should not increase the size of the packet where the PMTU protocols are messed up. So PMTU should be able to work seamlessly. So the concept of creating a clone of the live traffic, ability to do the truncation, and then drop. That was a concept which was needed. And then there was some limitation we wanted to put on the amount of metadata which need to be inserted in the packet. So that's kind of thought through. On the performance side, this is something which the question I had earlier in the presentation, that have we discussed it with the silicon vendors, the proposal? Because one of the the cost of implementing this in hardware, given that this is a data path feature, if it is too much, getting the backing from silicon vendor will be very difficult. So what I'm proposing here is salient points that we should not rely on DMAing the next cell of the packets into the hardware, which impacts the performance, not recycling the packet. All the edits on the packet should happen in localized field, should not go beyond certain local offsets, so that the hardware is very efficient. And that essentially helps the cost of implementation in the hardware. So that's kind of a rationale behind it. And the concept is very, very simple. It's very elegant. And I have backup slides on the tunnel packet, on the IP6 packets, on the IPv6 packets, and it looks very, very elegant. We don't need to allocate a new ether type. We have to allocate an INF protocol type for the IP header, which is a challenge. But besides that, there's nothing else which needs to be legioned or allocated. So we essentially define an upper layer header, which sits as an IP header, a next header extension. And in that case, there is a copying of the IP protocol, which is done in the IFA header, which is the upper layer protocol. And then the hardware knows whenever the IP protocol is this proto IFA, then it has to pick the actual protocol for the hash computation from the copied information, which is coming here. So that's one part of it. And if you see, the metadata is actually treated as a layer 4 information, and it sits after the layer 4 information. And essentially what it does, it helps to keep the various computation which relies on the L4 information. So that's pretty much it. And my request is to look at it, poke at it, but the proposal, in my opinion, is very, very elegant and works seamlessly for V4, V6, tunnels, as well as the MPLS. And we have a side meeting today at 5 p.m. And I will talk about MPLS as well. In this, I have some brief conversation with Kriti on this. He gave me his input, but that's what it is.
Okay. So can we skip back to the layout of a packet? So my question is, why bother and try to insert data, measurement data or telemetry information into the data packet?
Into the data packet?
Yeah.
Yeah. So depends what information, and that question is in general. That question is applicable to the in-situ UAM as well. It depends what information you are trying to gather. If you are trying to gather the information about the network and network alone, then your statement is right. But you want the information about the network in a context of an application, then you need the live data.
Right, but you don't have to insert it into this packet.
So creating a correlation out of band or in band, that's two different ways. And in this scheme, we create a correlation in band, which also gives us, just to answer, ability to do functions in the hardware and do not burden the collector subsystem.
Okay, I'll want your attention when I will have 5 minutes on hybrid two-step.
Thank you.
All right, we hit the 5-minute mark very, very quick.
Tom Mizrahi, Huawei. Would you be able to achieve your goals using the IOM header and the data field format?
So for the V4, V6, and IPv6, we were not able to achieve the goals, and that's how this proposal came.
Okay. I would be glad to hear more about it on the mailing list or whatever.
Sure thing.
All right.
Thank you, guys.
Thank you. All right, we have Rakesh. So now you had 2 different decks.
So I have 5 plus 5, or is it 5?
Can we do just 5?
Just 5?
Yeah.
Both of them?
Yeah.
Hi, everyone. My name is Rakesh Gandhi, and this is the first time I'm presenting in IPPM. So we have this couple of drafts for performance measurement in Spring Working Group. They are for segment routing. The first draft is for the MPLS data plane. It's an informational draft. So both drafts that we have they rely on the RFC 6374 and RFC 7876. So those are the existing RFCs, and the focus is that how we use them for segment routing. So in some sense, they are not defining any new protocols per se. So for the first one, the agenda, the requirements and scope. So both drafts are for the probe messages, for the SR links and the P2P and P2MP SR policies for the delay and loss measurement. So there are a few things that go with it in different RFCs that we have put them together. So as mentioned, delay and loss measurement and the extended the T metrics for the delay and loss. The scope is in this draft, the segment routing with MPLS data plane, the probe messages, and the two RFCs that we mentioned, and informational in nature. So for links, the probe packet is sent with the GAL as defined in the RFC 6674. For policies, they are sent with the label stack. The RFC defines the GAL and gas values for the delay measurement, for less as well as for loss measurement. For the probe responses, the RFC 7876 defines the URO TLV for out-of-band reply. And for the two-way measurement, the reply is sent the same way as the query. There is a path segment ID drafts. You may have heard about it. So we use them for the loss measurement for accounting traffic. There are a few RFCs. They advertise the extended T metrics for delay and loss. So once we do the measurement, we can use the values for the metric advertisements. So we welcome your comments and suggestions. And as mentioned, those are existing RFCs, so implementations already exist. And this is for the Spring Working Group. We would be requesting adoption for it. Right. And the second draft is defining the UDP path. So when we have segment routing with IPv6 data plane, there is no GAL support. So we are adding UDP port to punt the RFC 6374 packets. So again, we're not defining any new protocols per se. Same 6374, it's already been implemented. This one adds the UDP path for it. Again, requirements and scope. These are for the probe messages. For the there are few TLVs not present in RFC 6374 and it can be useful for segment routing. So we have added those TLVs. And as you know, the segment routing policies, there are ECMP along the path. So what we can do about them for performance measurement. So again, this is for delay and loss measurement for SRMPLS and SRv6 data planes. We don't need to bootstrap PM sessions. 6674 there is no such concept. It's stateless because there is a written path defined, so you don't need to have a state. We can do both one-way and two-way measurements and handle ECMPs. The scope is again the do RFCs and just adding the UDP path for the query messages. So as mentioned, there is one UDP port for the delay measurement and one UDP port for the loss measurement that's requested. And response messages, if URO is there from the RFC 7876, then that's used for the reply. Otherwise, response is sent using the information from the probe messages. So there is a return path TLV. It can contain either the segment list or the binding seat for SRMPLS or SRv6. So the RFC 6374 doesn't have a sequence number. We thought it's quite useful to have, so we have added the TLV for it. Again, the same RFC does not have a block number, and as you know, the 8321 alternate marking scheme requires block number or coloring. So we added a TLV for the loss measurement. As you know, there is ECMP for SR policies, and many MPLS, OEM, RFCs already talk about ECMP. So we can use the destination source address in the UDP, or SR MPLS, there is entropy label, or SRv6, there is flow label, if you want to measure the certain ECMP path. So we welcome your comments and suggestions. Again, those RFCs are already there. So implementations are there as well. So in the spring, we will be asking for working group adoption. Thank you.
Just a couple seconds over.
Okay, couple comments. First, in your first presentation, you erred on label element. There is no EXP field. This field was renamed a traffic class several years ago. Second of all is that this draft, I believe, doesn't have any archival value. It looks more like design specification, and I don't see the value of discussing and adopting it, less adopting. For the second presentation is why not to use OWAMP, TWAMP, or STAMP over SRv6? Why invent something? Because these protocols are for IP network, and segment routing in IP network or IPv6 is nothing different from IP network. So why you cannot use that? And it already gives you sequence number. On another point is 6374 is quite well equipped to do synthetic loss measurement. That's where you need a sequence number. So you don't need to invent any new TLV for 6374. So
I think those are all good points. Maybe we can discuss offline given the time we have.
I stated it earlier many times, but I don't see that authors listening. Thank you.
Yeah, so only one comment is that the 6374 is defined for the MPLS TP networks. So when you read the RFC, it says this is MPLS TP, so you don't know how it's going to work.
You are mistaking again. 6374 is generic. 6375 is MPLS TP profile of 6374.
Okay, thanks.
Hey, Barak, that's just a short comment. I'm actually concerned about the ECMP comments that you made. Most devices, and the good practice is not necessarily to use MPLS entropy labels, and also not always to use the flow labels. And if you change the UDP deport, then I don't see how this system works.
All right, you can talk. Fine. All right.
Okay, my name is Tal. I'm from Huawei. This draft is a joint work with Carmi, Giuseppe, and Mauro, Mac, Vero, and Greg. A bit of background. The idea in alternate marking, we want to be able to measure the traffic between two measurement points, MP1 and MP2. That means loss, delay variation. RFC 8321 defines a way to do that using a marking bit. The marking bit changes periodically. It also defines double marking, where you have two marking bits. One is changed periodically, and the other has its value set in a single bit, in a single packet in each period. And that allows you to measure both loss and the delay in an accurate way. So this is already defined in RFC 8321. This draft defines new alternate marking methods, which allow you to use a single bit per packet with the same level of accuracy as the double marking method, or to use 0 bits per packet. So it defines a few new methods of alternate marking. It also summarizes the existing methods of alternate marking. So we have kind of a summary and comparison between the methods. So if you're defining a new network protocol which requires the use of alternate marking, you can use this comparison and this trade-off to decide which alternate marking method is best for you. Now, there's a pretty large number of drafts out there which make use of alternate marking or make use of something very similar, including some of the drafts we saw today or we'll see later on. There's a draft by Tianran which wasn't added here yet. And actually also the multi-point marking draft, which was presented by Mauro, which is now a working group item, uses some of the concepts from this draft. So first of all, we believe that quite a few of these drafts can make use of the current draft. We believe that the authors of these drafts should certainly be familiar with the current draft. We'd be happy to hear comments from these authors. So I certainly believe that this draft is something that should be reviewed. We'd love to hear comments about it, and that's at least the first step. After that, we'll ask for working group adoption. Comments?
Yes. Greg Mirsky, ZT. So I'm one of the co-author. I really encourage participants of the working group to review it, because as listed documents in other groups that discuss applicability of alternate marking method in general to their overlay encapsulations. So to be more conservative of allocating space for marking field, we are relying on availability and progress of this compact marking method, because it allows to use a 1-bit marking flag and achieve accurate measurement for the packet loss and delay.
Right. Sam?
Sam from Google. Does it work for any cache traffic?
We haven't considered that yet. Good question.
What was the question?
Does it work for any cache traffic? Thanks.
All right, thank you. 1 minute early. All right. Next, I think Nalini. All right.
I'm gonna keep this short. Hope you guys can all hear me. Okay, so what this is we talked about it last time. It combines PDM and the marking method. I'm gonna go kind of quick because there was only one issue that was, a couple issues that were brought up, and this is a resolution to one of them. Okay, so basically, what we're doing is PDM is a destination option. It's end-to-end. We want the hop by hop. So basically, if you think of trace route, but hybrid measurement and in the packet, then you got what we're trying to do here. Okay, so this is in PDM, round trip delay, but doesn't have one-way delay or middle box delay. So PDM is wonderful, but then if you have a problem, we need this. Okay, so let's stop a second here. So the problems is that we have defined this hop by hop header for V6. We had a middle box identifier and then a timestamp in and out for obvious reasons, but it's a 16-bit timestamp. So the question was, how are you going to do that? What's in that timestamp? Okay, I know it's like out of alignment. So if your eyes are crossing, there's a reason. Okay, so since it's 16 bits, what we said, and timestamp obviously is bigger than that. So we made this a delta field. So basically we pick a fixed point in time, January 1st, 2019, because that's probably the first time we'll have an implementation. And all the 16 bits, all the timestamps in and out are just deltas off of that in, I believe we have nanoseconds. Something like that. I mean, it's a pretty simple concept, pretty easy to see. And the thing is and it actually doesn't even require time synchronization from one middle box to the other, because it's really inside that middle box. And so that's kind of the thing that you get. So with this, what you'll get is, so let's say you have a big fat hop in the middle, you got a satellite link in the middle. This could be super useful. There was some talk about performance enhancing proxies. Well, they could certainly use this. If you have a middle box on your network that's causing you delays, we can help you out there. That's kind of the functionality. So any comments? Everybody love it? We love it. No. No comments? My God, what is wrong with everybody? Am I like, does nobody care? Mike, get up and tell them everybody how you love this and how it'll be so super useful. I mean, it's a really super simple concept. That's all I wanted to do is if it's simple, it's easy to do, it'll be easy to understand, people will use it. That's the idea, simple.
Tal Mizrahi, just a small comment regarding the timestamp field. We have a draft in NTP which defines guidelines for defining packet timestamp formats. We'd love if you could read that and if you could see whether it fits the way you define the timestamp.
Sure. Let's talk offline. But other than that, I think it's as I say, I can give back a bunch of time because, as I say, it's a really simple concept, what we want to do. We
Sure,
like that.
thanks.
Okay, thank you.
Thank you. All right. Greg.
Okay, so this will be an update. So what we're proposing, the method to do on-path telemetry collection, but it's a split into their measurement and collecting. So this protocol, it doesn't define how the measurement are done. There are some suggestions, recommendations, possible options, but it defines how the collection on path is supported. Similar solutions can be found in PTP follow-up messages, where there is sufficient characteristic information included in a follow-up packet, so it can be used to do residence time measurement or delay measurement to improve clock synchronization. And then the similar technique we used in residence time measurement in propagating 1588 over MPLS domain. What is proposed? So this is just a diagram of HTC domain. We have an egress node, and we have transit nodes and an egress node. And so packet represents the data. The trigger is some condition that triggers the measurement. And then there is a HTC follow-up packet that being injected by the ingress or possibly transit nodes and is consumed by the egress, so that this packet should not leave the domain. So the operation is quite simple. The document now includes more detailed description of the mechanics, but their catch is that depending on where this applied, their characteristic information to ensure that HTC packet follows the same path of their data packet or the trigger packet. That's encapsulation specific. So the follow-up packet has transport network encapsulation and then HTC shim layer. It may include optionally the profile, so to characterize what telemetry information to be collected, and then followed by data collected. One of the specifics of mechanism that is in HTC is that we are not bounded by the size even of a single follow-up packet, because there might be a sequence of follow-up packets on the same path triggered, caused by one trigger crossing all the transit nodes. So that overcomes the restriction of the amount of information to be collected. So comments, suggestions, we're open for new offers, contributions, and would like to consider working group adoption. Yes, please.
Great. Two questions. One is that how do you identify the packet need to be dropped at the edge?
Because HTC will have its own type.
Okay. And second question is that you preserve the original transport encapsulation, but the path may also depend on the other fields, which are the layer 4 information.
Okay, so basically what we have, and that we're going into specifics of what's in document. So there are certain mechanics that transit node wait for, and how we limit the number of outstanding flows, HTTC flows, for the same service, so that basically if there is some like recursive, okay, let's take example SFC recursify in between of SFP, right? It can change the path. So then it will be generated new follow-up packet, which will go to the end, to the egress, and then egress can really put them together and correlate. But
okay, thank you.
yeah, but again, there might be some edge scenarios that we haven't considered, so I appreciate your thoughts and comments and discussion. Okay. Hope it's not me. Thank you.
Thank you, Greg. All right. So. Okay.
I'm Shami from ZTE. Here's a quick update on the IOM conf state 01 version. Firstly, I want to recap the intention of this draft. This draft provides a method for the IOM encapsulating node to determine the IOM header. Actually, it's a dynamic acquisition. Traditional OM mechanism such as ICMP or MPLS SPP can be used to convey the IOM configuration data. Here's the principle of this draft. As shown in this diagram, the IOM encapsulating node can get to the IOM configuration data from all the IOM nodes along the path. The IOM encapsulating node can send echo request to each node along the path and receive echo reply from this node. And through this process, the IOM encapsulating node can get to the IOM configuration data. There are main two changes introduced in the 01 version of this draft. First change is MTU. MTU is a key issue for IOM in-situ OM. And in section 4.2 of IOM data draft, it says the maximum number of hops and the minimum pass MTU of the IOM domain is known. This change in this draft provides a mechanism to know the minimum pass MTU of the IOM domain. The second main change is time step. In the 02 version of IOM data, it introduced a new format of time step. Currently, it includes PTP, NTP, and the PIX, POSIX. This change in this draft enables the IOM encapsulating node to know the format, the length of the time step that's configured at the decapsulating node. Next step to ask for more review, revise this draft, and then maybe ask for working group adoption. Any comments?
Any comments? Thank you. All right, got a couple minutes back. Let's try to go quick. So we have 3 more people scheduled. If we go over time, we may have to drop the last ones, but these slides are up and available.
Hello, this is Hao Yu from Huawei. I'm going to present an alternative method to the in-situ OAM. So we all know the data plane telemetry. Now we prefer to use the in-band monitoring. So IOM is a perfect way to do that. It basically is a way to do the in-band network telemetry. It can directly carry the data in the user packet and reflect the real-time experience of user traffic. However, we can use a passport as an analogy for the Institute OEM. In that, we will stamp the packet with user data collected at each node and accumulate stamps. And at some point, we can extract the stamps and ship it to some collector. The data it has some advantages. For example, we don't need to correlate the data because they all go together. And so data is self-describing. And also we use a single packet to export the accumulated data. So the overhead is low. And we don't need a lot of configuration to the network nodes because we carry the instruction in the packet. However, as IOM also have some issues. First, we need a lot of data header parsing and processing, and that might incur some performance penalty. And also, we'll keep increasing the packet size. There are some MTU concerns or the packet processing issues to the system net data plane device. Also, we introduce some encapsulation issues. For example, people have pointed out it's difficult to encapsulate in IPv4 network. Also for the MPLS. Unfortunately, those two type of networks are most popular today. And also, the data must be instruction. The data must be carried in the plain text. That might have some security concerns because if you intercept the packet or you tamper the data, you don't know at the end node. And also, if the packet is dropped somewhere in the network, you will not be able to find where it's dropped. So we have alternatives. We call it PBT, postcard based. Instead of carry the data with a user packet, we just send the data with an independent export packet to the collector. So it basically we only need to configure each node to tell what kind of data need to be collected for each user packet. So we can see we can solve all the issues faced by the IOM, but it does incur some extra cost. Like we now need to correlate the data because we need to know which side of postcards belong to the same user packet. Also, we may slightly increase export overhead because each individual packet will have its own transport layer header. Also, we need some configurations in the device. So that's why we have the second alternative for that. We call that postcard-based telemetry instruction, PBTI. In this alternative, we also include the instruction header in the user packet, but we still just export the data with an independent IOM packet. So you can see here, this is kind of a trade-off. Now we also need to pass a packet, but the packet size will just slightly inflated with the actual instruction header, but it's no longer increase its size as a pass on the forwarding pass. It still has encapsulation issues, but now we don't need to correlate the data because in the instruction header we can carry the flow identifier and the packet sequence number, so we can easily to identify the postcards. So also there's no need to configuration because instruction header will carry all the informations we need to tell node what to do. So this I skip this slide. It's just a PBTI. Show the format of the instruction header. You can see something in addition to what has been defined by IOM. We also add the sequence number and the flow ID. We believe that's very useful. So next step, we want to collect more feedback from the working group, and we are actually building the prototype on this, and we likely to ask for adoption later. Thank you.
Okay, I'll quickly add two information. The first one is that we found some of this scenario need this postcard-based telemetry. So that's later had a draft that's used for the IPFPM. We can use this the postcard because we need the IPFPM use per hop to detect the packet loss ratio and the delay, so that maybe use the postcard-based telemetry for this scenario. Second one is talk to many customers. They have much concern about the existing change of the encapsulation because of the SRv6 network programming and IOM. So that seems that the header of the packet increased bigger and bigger. So they much concerned about the existing network devices. So the postcard method is also one way to try to reduce the requirement to upgrade existing devices. Okay, thanks.
All right, so we are out of time. So we've hit our time limit overall. So we have 2 more lightning talks that had been queued up, but I don't know. The slides are posted, so I think we're going to have to push those out. Apologies for that. All right, so thank you, everyone. Do we have the blue sheets signed back? All right, I'll click this. All right, thank you, everyone, and we will see you in Prague.
It's fine. It'll be available. I'll just grab it. Yeah.
Okay, so I just